Hey Olive, I just got your email this morning, and I was actually starting to type a response back to you, and I thought it might be easier to record a video to kind of show you kind of what's going on. So I just talked about this with my Math 105 class. Let me get in here real quick. Sorry, I probably should have done this before I started recording. Stats, PowerPoint. Here we go. Okay, so here's an example of misleading with vertical exaggeration. I'll show you an older and then a newer, and then if can find another one really quickly, I'll show you another super recent example of misleading with it. So the one I always used in class was this one. So I want you to take a look at this with me real quick. Oops. So what you see here, this is an old graph from the broadside when they were they were commenting on increases in tuition. I think it was $4 a credit. I think that's right. Because if you look at this graph right here, the old tuition was $528 for 8 credits. The new tuition was $560. So that means that the difference between these two is the increase. So for 8 credits, it went up $32. So that's $4 a credit. Okay. So here's the vertical exaggeration. This looks very steep. If you look at this, it looks extraordinarily steep. And the problem is if you think about this being 560 and this being 528, that means I'm going to do a little bit of cutting and pasting here. We're going to play in Paint, one of my favorite programs to kind of mock up using mathematics. It's a little bit ghetto, but so this right here. Let me draw a little. That is $32 right there. That little difference right there is $32. Okay. I mean, it has to be, right? If that's 528 and that's 560, the bar graph, the height shows the value. So the change between the two of them has to be the difference, which is $32. Okay, so the problem with that is if you take that little ruler right there and you use it as a ruler here, that means that's $32. That's 32 more bucks. And then there's not even enough room to put a whole nother one down. So that looks to be maybe half. So you've got 32 plus 32, which is 64, plus half of 32, which is 16. So this is really, this distance right here, in all reality, is not 528. Instead, it appears to be closer to 80. But you see, they just put the number 528 there. Well, that by putting 560 next to it like they did here, they've given you information that's not apparent in the graphic, that this difference has to be 32, which means this distance here is 80, not 528. Which means what's gone on is this bottom number, which your brain perceives as 0, actually isn't 0. It's more like 448. It's more like 448. So this bottom number down here, I'm going to put that 448, is more like that. Now let's just see if that pans out over here. Okay, so at 12 credits, at $4 more per credit, this should therefore be 4 times 12 or $48. Okay, which makes sense because if you add 48 to that, you get that. So that pans out. But the problem again is one of the scale, because if that's 48, let's just copy, paste. So that's 48. That's 48 more, up to 96 now. And then we've got maybe 3/4 of that? What would you call that? 3/4? Maybe just past 3/4. So you've got 48 times 2 3/4, which is 96 plus 32. This is hurting my brain this early in the morning. 96 plus 32 is $128. So this, if I did that math right, I hope I did, this is really 128. And this is all, I'm just eyeballing this. We can get a ruler out and make it more precise if we want, but I think you're getting the point. So really, this, again, your brain is programmed when you see bar graphs that this is 0. But the problem is that this is actually only $128 down from $792, which means this is even this isn't even scaled correctly, because what they've done now, again, assuming that I've done all this kind of eyeballing correctly, is the base here is more like $550 or something like that, which I know is off at my 448, but the point is that it's not zero. And you'll see the exact same thing for all these bars. So what I ended up doing with the broadside was I said, hey, to not mislead your public into thinking these are huge jumps, i.e. vertically exaggerated, what you should really do is make sure that your axis starts at zero. If you start the axis down here at zero, then all these relative sizes are actually totally legit. Like, that's $32. And if that's $32, then this clearly is the 528 that it's supposed to be. This is $48. And if this is 48, then this is the 792. Like, everything's to scale that way, if that makes sense. Hopefully that makes sense. So the idea of vertical exaggeration is one of, if you truncate your x-axis, or your y-axis, your vertical axis, if you truncate it and start it somewhere other than zero, you're going to get exaggerated slopes on the vertical. That's what happened here, is if you back up here, these slopes seem much steeper than these. And they are, because the mathematics of what happens is, horizontally, nothing's been changed, but vertically, this distance is disproportionate to what this should be. This distance, although it's very small, proportionally, visually, looks very large when compared to this. Hopefully that makes sense. Let me see if I can find another one where they do it wrong. That's confusing. Let's not look at that one. Here's a pretty good one here. Gallup does it all the time. They do it all the time when they make line graphs like this. So you can see they're talking about U.S. obesity climbing to a record high. Okay, record high. That just, don't worry about that. But you see how 28.0, yes, definitely is larger than 27.7. That's 100% correct. But what we're going to do right now is we are going to Olive. We're going to do a little bit of something here. I'm going to pull Excel over here. We're going to create a quick little graph for you. How's that sound? I'm going to put the image here. And we're going to remake this graph. We're going to start at 2008, 2009, 2010. And we'll copy it down to 2015. There we go, 15. I'm going to put the percentages in. So that's 0.255. 0.265, 0.266. I'm just copying the numbers over. 0.26. Whoops. 0.261, 0.262, 0.271, 0.277, and 0.28. All right, we're going to make the exact same graph they just made, which is a line graph with points, I believe. Yep, and it's being a little bit annoying, so I'm going to have to reselect the data here. We're going to edit. It's got me having two. I don't like that. Here, let's do it this way instead. Sorry. I'm going to start with a scatter plot. I don't know why the hell it just did that. Scatter plot. There we go. There it is right there. Now notice, this looks just like theirs because it's crazy jumps in the graph. If I can connect it. Hang on one second. I'm learning something as I go here. Let's format the data series and let's add a line. Yeah, let's add a. There we go. Now it looks just like theirs. Well, not just, but close enough. Okay, but the problem is you can make this not look anything like theirs, i.e., make it look correct by simply making the vertical axis start at zero, and then you get this little change right here, which is hardly any of a change at all. It's hardly any of a change at all. Now, backing up, realizing, yes, these are percentages, and they are percentages of ostensibly U.S. adults. So 1% change is like 3 million people. Totally get that. And we talk about that in class and what the other problems are with the actual measurements that are being done. But the point is that this looks more exaggerated than this does because their scale, again, looking at this scale, let's move this out of the way here. I said, let's move this out of the way here. There we go. Looking at this scale, your eye goes here and thinks zero. And that means that from here to here is 25.5. Well, if there to there is 25.5, then there's no way that can be 1. That's more like 8 or 9%. So your brain is being tricked vertically when it doesn't have a good reference point to look at down here on the vertical. When you start at something other than 0, you tend to get exaggerated vertical slopes. And I think, unless I'm completely misunderstanding your question, I believe that's what they're talking about with vertical exaggeration. Let me know if I'm not right, but I think that's what they were getting at. So I will get this video to you, and hopefully it helps. And if not, shoot a note back and have fun down there in Southern. We'll talk to you soon. Bye, Olive.